Hello everyone and welcome to today's video, Powers of 2. As some of you may know, today is Good Friday and Sunday is Easter Sunday. However, if you don't celebrate, just have a good weekend anyway and enjoy the video. These are some simple facts about Powers of 2. Fact number 1. The order of the ones place is 2, 4, 8, 6. Don't believe me? I will prove it to you. Another fact is always even. I'll also prove that to you. Go on forever and never end in 0. If you don't believe any of these facts, I will prove them to you right now. Here is why the powers of 2 always end in 2, 4, 8, or 6. So, if we follow the sequence of the powers of 2, we will get 2, 4, 8, 16, then we'll go back around to get 32, 64, 128, 256, then back around to get 512, 1024, 2048, and then 4096. As you can see, this column all ends in 2, this column all ends in 4, this column all ends in 8, and this column all ends in 12. These are all the squares I know by heart, or all the powers I know by heart, but I guess if we kept multiplying, then we could probably find the same pattern. So, if I take 4096, multiply by 2, then we'll get 8,192, and then 8,192 is 8192 times 2. 16,384, and then if we did that times 2, we would get 32,768, and then multiply that by 2, we'll get 65,536. Well, we've proved it, but why is it true? Well, it's true because 2 to the first is 2. We start off with 2. And then to find a power of 2, you multiply a number by 2, or another power of 2 by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So as you can see, if we multiply something that ends in 2 by 2, we're going to get 4. And if we multiply something that ends in 4 by 2, it's going to end in 8. If we multiply something that ends in 8 by 2, it's going to end in 6, because 16 ends in 6. So because our powers of 2 start off as 2, 4, 8, 6, or 16, we are caught in the never-ending cycle of 6 times 2 is 12, so it goes back to 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 6 times 2 is 12. We take the 6 and not the 16 because the ones place for 16 is 6, so we can just ignore that 1 for now. Claim. Powers of 2 are always even. Well, this one is kind of obvious. 2 itself is even. And to find a power of 2, you have to multiply 2 by 2. And 2 and 2 are both even. So something even times something even will make something even. Then we multiply 4 times 2. 2 is still even, so that's gonna be even. Multiply by 2 again, still even. And then 16 is even. Using this logic, you can assume that any power of x is even or odd depending if x is even or odd. Let's say x is 3. Well, 3 and 3 are both odd, and an odd number times an odd number is still an odd number. Then we multiply by 3, which is an odd number, and we'll get another odd number. Still multiply it by 3, an odd number, to get another odd number. And it will just go on and on forever as odd, which is why any power of 2 is even. Because if we follow the general statement, any power of x is always even and odd, depending whether x is even or odd, then I can fill in x is 2, which is even, and every power of 2 will be proven to be even. Claim. Powers of 2 go on forever. Well, this is true because there is infinite numbers. And as long as there are infinite numbers, there's gonna be even numbers and odd numbers, because there's an even number every other integer. So, as long as there is infinite numbers, there's even numbers, meaning that there's powers of 2 forever. Final claim. Powers of 2 never end in 0. Well, why wouldn't they ever end in 0? First, as you can see from our 2, 4, 8, 6 pattern, they don't end in 0. They only end in 2, 4, 8, or 6. But why? The only thing, when doubled, that makes a 0 is 5. Because 5 times 5 is 10. No other number, or 5 times 2 is 10, I'm sorry. Or no other number, when multiplied by 2, creates an integer that ends in 0. And, as we can see, there's also no 5 on this list of 2, 4, 8, 6. So none of these numbers can be doubled and make a 0. Because we proved 4 things today, I think this deserves a squirt from our celebratory bottle. So, that saying, congratulations everyone! Today, we did a lot of proving. Let's do some actual squares. Let's find some actual powers of 2. I decided to go up to 24 because 24 is my lucky number. So, here we go. And I will put up a list of them later so you can screenshot and take reference, because you can't really see the board that well. So, let's get right into it. Alright, I know half of these already, but I will go through them with you. So, 2, 0, 1, 2, 1, 2 times 2, 2, 2 times 1, 2, 2, 2, 2 times 2 is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64, 2 to the 7th is 128, 2 to the 8th is 256, 2 to the 9th is 512, 2 to the 10th is 10 24. Hey, that's kind of cool. It starts with 10. It's 210. 2 to the 11th is 2048. 2 to the 12th is 4096. 2 to the 13th is 8192. No. 8192. 214 is 8192 times 2. 16,384. That times 2 is 32,768. 2 to the 16th is 65,536. And 2 to the 17th is... You can do this with me as well. You can pause it and just try and figure these out yourself. $131,072. Let's just say 131,072, and I will check this later. 2 to the 18th is 131,072 times 2. 4, 1, 1, 2, 6, 2. 262,144. We're almost done. Over halfway there. 262,144 times 2 is 524,288. I checked all of these answers and I got all of the ones I did right, which was surprising because I was rushing so I wouldn't take too much of your time. But here is the list from 2 to the 0th to 2 to the 24th. Goes 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1,024, 2,048, 4,096, 8,192, 16,384, 32,768, 65,536, 131,072, 262,144, 524,288, 1,048,576, 2,097,152, 4,194,304, 8,388,608, 16,777,216, and that is the list of powers of 2 from 2 to the 0th to 2 to the 24th. Thank you for watching today's video, and as always, have a wonderful day, night, or whenever you are watching this. I am not sure what the next video I'm going to make is, but it might be something to do with Fibonacci numbers, which is a sequence made by the mathematician Fibonacci. I don't remember his first name. And it goes 1, 1, 2, 3, 5. Basically, the next number is determined on the sum of the last two numbers, and I will give you the equation for that in that video. Like I said, I hope you enjoyed this video, and stay happy!